So I guess you're expecting some speaking now? Is that why this is all so quiet? Yeah. So welcome, party people. Hope you're excited. Who here went to any of the earlier defending against PowerShell attack stuff? I was there. Okay, sweet. Anybody go to the Revoke or Invoke Obfuscation or Invoke Cradlecrafter stuff? Ever wondered what it looks like to have an InfoSec Voltron where red team, blue team come together for a great superpower?
Who's red team in that equation?
We're gonna find out, aren't we? We're gonna talk today about Revoke Obfuscation. This has been a long, long path, a very exciting path of all the crazy stuff that people can do in PowerShell to avoid detection that ends up becoming this twisted knife in the heart when you finally start looking forward to it. I'm Lee Holmes. I'm architect in Azure Management. I was an original developer on the PowerShell team, wrote the PowerShell cookbook, and did a bunch of fun stuff. If you want the brief format of this presentation, the slides are shared on that link right there. Just run it in PowerShell. You'll be in good shape.
And my name is Daniel Bohannon. I am a blue teamer. Ha ha ha. No, seriously. Okay, so I'm a senior applied security researcher for Mandiant. Prior to that, did IR consulting with Mandiant, and yeah, just really enjoy looking at evil and obfuscation and evasion techniques in different and obsessive ways, I suppose. And there's my Twitter handle right there, and a little. You could run this command also on your computer, and it actually would be a lot more appropriate than what this guy just told you to run.
But trust anything we say. By the way, that was an H in Daniel H. Bohannon, not just Daniel Bohannon. I've sent many people to the wrong Twitter account, so. But at least they're not getting cookie recipes from the other Lee Holmes out there, so. So we're going to start off with kind of a treatise on blue team follies. Who here today uses 4688, the command line logging, to do a lot of their detections? Yeah, you got it. Now, one of the things we're going to talk about, so as a preface to all this, you got to have logging enabled. There's a couple of good ways to do it. Sysmon, get 4688 enabled. The attackers don't like to do this for you. They're nice, but not that nice. So it's really in your best interest to do this before they get in and before you need the logs. You can also do real-time process monitoring with uproot. Of course, the PowerShell script block and transcription logging. So that's a context, right? So you're a mature company, you've got logging enabled, and now you're going to start hunting evil. So here's an example. You're going to be looking for somebody who's trying to call CMD to call PowerShell that does some stuff, right? We're all aware of the traditional download cradle, PowerShell doing some stuff. So you start writing a signature that looks for example, write host success. You run it in CMD, it runs some PowerShell. On the screen, you see that. So what might you do if you're going to try to detect this kind of 4688-based command line logging? Well, what you might have first started doing was writing a signature directly for PowerShell-command-no profile-encoded command, all that kind of stuff. Everyone here probably has some detection like that in their systems. But here's one of the things. PowerShell is a great thing. PowerShell help is a great thing. One of the things that PowerShell help does talk about is you don't need to provide all input at the command line itself. You can also pass in command line input from standard input. So here's an example, right? That very first example was write host, that was one way. But you can also echo content into PowerShell. PowerShell will run that. Or you can pipe it into PowerShell through the invoke expression commandlet. PowerShell will run that as well. All these run. Now already you're bypassing anything that was doing straight parameter lookups based on a well-known string. So this is starting to get a little bit scary. But, you know, you got some options here. If you take a look at this, the main command line showed just PowerShell dash. Maybe you're kind of screwed there. But what happens if you look at the parent process? Yeah, you saw what they were doing in CMD itself, CMD calling PowerShell. So maybe what you're going to do here is start to write some detections of CMD calling PowerShell with some malfeasance. So Is it safe to do that? No, 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 no. CMD is also a pretty smart language by some definitions of smart. You can do things like start to concatenate strings in CMD, set that into a variable, and then pipe that into PowerShell. So now you're getting into the world of traditional obfuscation, and this is what you're going to see in the parent command line. So no longer do you see these static strings. Now people can start to monkey around with it. That's bad news. This is an example of this actually being used in Fin8. You might recognize this, CMD calling something else. This is exactly what we just showed. So this isn't hypothetical like Debo like breaking the world. This is like actual stuff happening in there. So being aware that this kind of obfuscation can happen in your 4688 event logs is really important. There's a couple other things too. You don't just need to send it in through standard input. You can also do things through environment variables, for example, having CMD set an environment variable and then have PowerShell read through that. And it could be directly through the PowerShell's env representation of environment variables, or maybe it comes from something more like .NET scripting. So you're starting to get in some real big danger there. Or here's an example. What if you use the clipboard as your data transfer mechanism? CMD dumps something into the clipboard, PowerShell reads from the clipboard, and invokes that stuff. So you're starting to feel like a little bit less confident in that PowerShell-NOP-execution policy bypass. So obviously, you start to do things like, I'm going to look anytime CMD is calling PowerShell with some of these things, maybe that's the right answer. Maybe we can just do some detection based on that, parent and PowerShell. Unfortunately, not. What happens if you have CMD creating that command to call CMD to then call PowerShell, right? So you obfuscated this one-to-one relationship, and now you start talking about, I've got process trees that are doing some of this bad stuff. Does that work? Is that going to be okay? Unfortunately, not. You try to do this, and the CMD ends up interpreting it all, so maybe you're safe there. Or maybe not. Maybe you escape this thing, and the CMD stops interpreting that first pipeline and goes on. And yeah, Bob's your uncle. What you see there is CMD calling an environment variable, and that's about it. So maybe you get smart and you say, okay, obviously 2 is not enough. I need to look at 3 processes or 4 processes. Maybe you start looking at trees of execution and starting to piece together everything that's happening down this path. Maybe that's the right way to go about it. So is that going to work? Sometimes. It's going to help. But it's not good enough because there's a lot of ways to pass things between PowerShell and CMD and the launching application in PowerShell without there being a lineage based on the process tree itself. So here's an example. Maybe you set a window title, and then you have PowerShell scraping a window title. You can dump content into files. You can dump it anywhere. You do not need to have a shared parent process tree. So that's not going to work out. Now, throughout all this, we're going to be using this shield icon. The good news is all of this stuff that's kind of obfuscating stuff as it gets to PowerShell, all of this stuff is caught in the PowerShell script block and module logs. Enable these things, it's all good. All good? Maybe not. The bad news is there is some stuff that you still have to deal with that can last into the script block logs, and then you need to look at the command line logs themselves to start dealing with them.
Yeah, so let's take a look at this. So as Lee was saying, if you're having a lot of your detection based on command line arguments for the initial launch, the real big benefit of PowerShell logs is no matter how it gets launched, it's still in the PowerShell logs. But what pitfalls might there be for defenders to make sure that we take into account obfuscation that persists into some of those logs? So we're going to just extremely quickly go through this example of the most basic remote download cradle, just this one-liner in-memory execution of this remote bit.ly link, which is totally legit. And attackers love this command because copy and paste is easy. Veil, PowerSploit, Metasploit, like all the frameworks out there are using this one-liner.
And it's pretty simple. So like the obfuscation options are limited.
Exactly. Yes. Let's go with that one. Let's go with that. There's not much we can do here. So as a very hopeful defender, let's just say, okay, if we see this, whether it's in PowerShell logs or command line arguments, and as a defender, if we start keying off of these 4 pieces of this command, this would catch this attacker command at the top.
It's legit. You get a raise.
Thank you. I will use that wisely. Actually, maybe there are some assumptions that we're making here that could be pretty darn dangerous. So maybe, as a helpful defender, we should enumerate these things and help the defensive community out, right?
Blue teamer, go on it, man.
Yes, this sounds like blue team MO right there. First we can see system dot really isn't necessary. That's going to be automatically appended by PowerShell. So if an attacker doesn't have to have system dot in their attacking command, as a defender, we shouldn't include system dot as necessary in our detections. So we're going to remove it from both of those. And as we keep going, we can see things like, okay, the URL. In this case, this is a string. And as a string, we could just straight up concatenate it in line like that. And so now that breaks our HTTP part in our detection. And it's not limited just to double quotes. We could say white space, single quotes, etc. There's a lot we can do there. So let's just go ahead and remove the quote from that detection also. When it comes to download string, a lot of defenders put a really heavy emphasis on this, and somewhat rightly so. It's the most common thing that we see. However, it's only one method of many from the net.webclient class. And there's a lot there. This is just a partial list. But you'll see some of the main categories being download string, file, data, and these basically bring down the payloads in different formats. Some hit disk, others stay in memory, some are strings, byte arrays, etc. But they're all valid options, and we do see attackers using these. So we could actually cover all of these if we just say .download as our detection. So we'll do that. This parenthesis actually isn't really necessary because that new object net.web client, we could actually just set that into a variable. Some frameworks do this and they call it WC, and then we just say variable name .download string. So again, we're trying to find the least common denominator in this syntax to make sure that we're kind of starting at the base, so we're not making bad assumptions of what an attacker has to have in their command. So we'll remove that parenthesis. Now, here's where it gets a little fun. So member token obfuscation. So in the context of PowerShell, it tokenizes each piece of this command to know what is this. Again, the URL is a string. Download string is actually a member token. And it's fascinating because you can do stuff like this. You can throw single quotes around it. You can put double quotes around it, which breaks our .download, right? But then what you can do, if you look closely at download string, you can throw a tick mark in front of it, and it actually works. And the reason is because the tick mark is PowerShell's escape character. But if you're escaping something that literally has no escapable meaning, then it does nothing, and it continues on just fine. So you can put a lot of tick marks in there as long as you stay away from those characters.
Who designed this piece of garbage?
Yeah. I don't know who would have ever allowed a scripting language to do this. That's insane. Ugh. And so anyways, being a bit obsessive, I said, man, I would really love, though, to put those tick marks in front of those special characters. So all you have to do is just uppercase them, and then you can do just that. So now we can throw tick marks in front of any character that we want. This is really exciting, right? The frustrating part is that not only is this what you see on the command line, but actually all the way into PowerShell script block logs, those tick marks.
Not sorry.
Those tick marks are still there. So as a defender, I have to actually really take this seriously, even if I'm going all the way to the script block logs. The important thing to keep in mind is that pretty much whenever you see obfuscation that persists into the 4104 script block logs, the source of truth without obfuscation removed is a 4103 module log. So hope is not lost. It's just not all in the exact same log. That's why it's important to test this stuff. And if there are tools out there that help you obfuscate stuff, it's really helpful to blue teamers to be able to do that, right? Yeah, all right.
Hypothetically speaking, of course.
Good. I'm feeling really good about this. All right. So as a defender, we could try to regex all the tick mark options, we could do that. I may or may not have tried that initially, but there's a lot of fallacies there, and I would just encourage you maybe not try that.
I have talked him off of a ledge more than once. All I'm going to say is that.
But if you do go that route, make sure instead of just the download methods, you also include open read, because that's also memory only, totally valid. It returns a byte stream instead of a byte array, and we have seen attackers use that. The reason I say not just regex to remove tick marks and stuff is that if you put parentheses around the member token, you can then treat it completely as a full-blown string, concatenate it, or set it in chunked variables elsewhere in the command, and it gets really nasty. So let's just remove that from our indicators as a defender. So let's keep going. Net.webClient. With this, we have tons of options. We can use tick marks if we put double quotes around it. Again, if we throw parentheses around it, we can treat it as a full-blown string, concatenate it, do whatever. Or in the third example, we can chunk it up into substrings anywhere in the command and then just reference those variables later in the command. So let's just go with tick marks and remove that from our Defender strings. So new object. So PowerShell is like really, really, really friendly and warm and inviting.
Yeah.
It is, yeah, it's really nice. So I actually accidentally happened into PowerShell. I was writing really sophisticated batch files. And a guy said, why don't you just change that .bat to a .ps1 and start PowerShelling? And I was like, well, what is a PowerShell? And so anyways, I kind of stumbled into it because all of my dir commands and stuff, they work. Like even though PowerShell has get child item, dir works. If you're from the Linux world, ls works. It just has all these aliases to make it really easy and user-friendly to get your job done without having to have really verbose syntax. That's really awesome for usability. As a Defender, that makes it a bit more challenging because any of those options are valid and will work. So we have to take all those into account. The good news is new object has 0 aliases. So I thought, sweet, this is going to be a really solid indicator. Yeah. The problem is that PowerShell is so helpful that it'll basically allow you to say, show me all the commands and functions that are available with this nice get command. So for example, in this screenshot, we're saying get command new -p wildcard. Show me all the commands that start with this or all the functions that start with this. And as you can see, PowerShell returns a really, really sexy PowerShell object. That's not just text there. Those are objects. Really awesome. Now, what does this mean for us here in this example? Is that if we take that object and pass it to invoke expression, it'll automatically convert it to a string, and the string will be new object, and it will invoke it. But we can be more creative than just invoke expression. PowerShell gives us a lot of options. It's pretty open-minded. So we can use the dot or ampersand because these are the invocation operators. And these actually act on the object being returned as an object. So this is new object. Now, what's fascinating here is if you remember those wildcards in the earlier example, what if as an attacker, we just started to replace pieces of new object?
What if you didn't?
Fair point, fair point. But if we did, and if people knew this was possible, then this is now new object. And the crazy part is this is exactly what it looks like on the command line and in script block logs, but in module logs, it does show up correctly. So yeah, there's that. In addition, get command also has an alias of GCM, and then it has an unofficial, undocumented, super top secret Lee Holmes way of aliasing this, and that is simply with the word command. Because
you get lazy sometimes, you know.
Because if you type something, PowerShell will be like, there's no functions named this, there's no commandlets named this. Did you mean get dash? Yep, you totally did, and so command works. So now, rewind any detection you've ever made where get dash is part of the commandlet. You totally don't need that, so you might not want to include it. You could also, instead of using wildcards, you could just chop up in substrings the string new object and use that in the last example down there. You could also go to PowerShell 1.0. So if you have never visited poshcode.org, it's a really awesome PowerShell script sharing platform that's been around for a long time, which means there's really old code in there as well as new code. And PowerShell 1.0 is stuff that a lot of defenders probably are not looking at. But that execution context, the beginning of each of those commands, that's an automatic variable, and it does really awesome, sexy stuff we should be looking for as defenders. And these are some of the ways that you can basically do get command with PowerShell 1.0. All of this, you can do the exact same thing with get alias. You're just working on, instead of the full commandlet name, you're working on the alias name. So you have get alias, you have gal, which is an alias of get alias, and then you have get alias's alias, which is called alias because you prepend the get. Got it? All right.
I think so.
All right, there we go. So we'll just go with one of those options, and yeah, so maybe we could try to still look for all these get command and get alias things, but we have to remember, since they're also commandlets, we could just throw tick marks in front of them, so we still have to keep that in the back pocket. We could also do the whole substringing, concatenating, or even reordering and pipe it into the invocation operators.
Any dads in the house? This really ticks me off.
Sorry, Lee. So again, we could regex all the things here, or we could just give up on it. That was a good dad joke. So we're left with the invoke expression, and hope is not lost. This is actually a really good indicator. Looking for IEX or invoke expression on the command line is like an amazing place to start. If you're not doing it, I highly recommend it. However, what things do we have to keep in mind with this? So it has the alias of IEX. Order doesn't matter. We can actually pipe expressions into IEX. You also, since it's a commandlet, you can just put tick marks in front of it. Since it's a commandlet, you can treat it as a string and then throw it into the invocation operators. And then this is the interesting thing. So as we'll get into in just a few slides, as part of this research of actually doing like blue team work, That's what it's called, blue team? Yeah, blue team work, yeah.
It's bleuet.
Bleuet, okay. So as part of this research, we actually got a lot of scripts and looked at them. And what we found is that only 3% of scripts in the wild use invoke expression, which actually sounds like a really small number, but that's actually an insane amount. So theoretically, you can't just say block all scripts that contain invoke expression because it's used quite a bit out there. The other thing we have to keep in mind is that invoke expression has a very close cousin called invoke command. Now, most people think of invoke command only in the context of running a script block on a remote system, but if you never specify a remote computer name, it will run locally. So what this means is that invoke expression will handle expressions, or strings, if you want to think of it that way. Invoke command is going to expect a script block. So you have invoke command, ICM, you can basically do .invoke or use the invocation operators, invoke return as is, invoke with context. There's lots of these methods to keep track of. And there's also PowerShell 1.0 that can do the exact same thing with this invoke script, which actually handles an expression or a script block, super convenient. And there's that execution context again. Again, you should be looking for that as defenders because it's really, really awesome and it's not really talked about that much. And you could also add in tick marks to all of those, of course. But what about that dot and ampersand? How can we feasibly, if we're trying to think of all the invocation operators and invocation ways of invoking code, right? How can we possibly as a defenders key off of just a dot or an ampersand? Well, maybe since we're dealing with script blocks, we could look for only if there's a dot and ampersand and curly braces, because a script block has to be denoted by curly braces always, right?
Yeah.
Right? Oh.
Oh. 2v8. Wonder where he got this song from.
Oh, that's so warm. Oh, here, you can have this one.
All right.
This means we split it, right?
Yeah.
You want the first half and I'll take the second half? All right. Come on, come on.
Oh, yeah.
Of course he's prepared.
Oh,
cheers. Oh. That's spicier than I remember.
Blue team power. Oh, the head.
That's fair. I deserve that one. Oh man. Okay. So script blocks always have curly braces, right? Not so. You can convert expressions or strings of script blocks. Two ways of doing that are the script block class with the create method, or PowerShell 1.0 once again with the new script block method. And you can obfuscate all of those just like we were doing before. So those aren't really silver bullets either. So it would really suck if there was like tools that just did this automatically.
Yeah. Thanks, Bo. How are you doing today?
So there may be a tool called Invoke Cradle Crafter that will loop all of these and many more different ways of invocating or invoking code and randomizing all of this stuff.
That is insane. Are you guys baked? My brain is baked.
So
that is brutal.
So
Let's take a break before we go into some like major blue team stuff. Like it's over.
So the really good news is that that's pretty much the extent of obfuscation today in PowerShell. That's totally not true. There's a lot more that we can do. We can then take it. At that point, we can take the command and then say, why don't I just treat the whole command as a string and then start obfuscating it at a string layer? So you can basically reverse it, and then in memory it gets reversed again. That's fun. You can then split the string, basically start putting garbage delimiters all throughout your command and remove them, either splitting and joining on nothing, replacing it with nothing, or concatenating it in the first place. So there's a lot more you can do there. And yeah, so again, with all these techniques,
thanks, Debo.
there may or may not be a tool that does a lot of this stuff. And so this exact example that we walked through manually, you can just plug that into invoke obfuscation and go through all these token layer obfuscations, right? And produce something random like this. And then you could just take all that, treat it as a string like we just said, and let's say reorder it and do something like this. And you can do that as many times as you want. And to prove that, APT32 has done it a lot of times, and this is a Vietnamese APT group, also known as Ocean Lotus, and they're particularly fond of doing one layer of token layer obfuscation and then like 4 billion layers of string obfuscation. So whenever these samples come in, then I get a lot of dirty looks in the office, and they just kind of slide that over to my queue and let me.
This is the world's tiniest violin. Poor boy.
So yeah.
Life must suck for you.
It does on those days. And so Invoke Cradlecrafter will take a very different approach to obfuscation. Again, looking at the same. Oh no, I see a question there. So the commands that we see in the wild, are they usually really long? Yes and no. We see all varieties. So yeah. The length of the command isn't just a good telltale indicator, unfortunately. So with Invoke Cradlecrafter, if you plug in that same URI, you can get something that looks like this. Again, totally different, no tick marks, no concatenation, but it's basically doing method enumeration to obfuscate the strings. So yeah.
It's not bad.
No, that's not quite as bad, but maybe something like this. A month or two ago, I pushed. This has been in my back pocket for, I don't know, almost a year or so. I felt like it was cruel to release it to the world without a way to like really robustly detect it. And so Lee, he didn't ever say this, but he kind of gave me the blessing. I felt like he gave me the blessing to release this to the world since we. So anyways, this is 100% special characters, and this is not my own idea. If you notice at the top, the Japanese researcher in 2010 came up with this. They wrote "Hello World" in nothing but special characters, and really incredible. And basically, it comes down to special characters, and their names are special characters. And so you could also have white space as the special character names like that. And I was talking with Casey Smith a few months ago, and he looked at this and said, "Oh, that reminds me of white space encoding." And I said, "Do tell more. What is this?" They said, "Oh, you use white space and tabs." And I was like, "Oh, that's awesome." So I sat down, and then you can do stuff like that. And so now the entire command, it does start with a little tick, with a little quote there, and the entire command is either white spaces delimited by tabs or tabs delimited by white spaces, and then they have a decoder at the end. So those are out there now as other encoding options, and this is. This is kind of the feeling, the vibe I'm getting right now in this room. And I'm honestly feeling really bad. I feel like we duped people here to coming to this blue team talk. Is there anything that we can do?
We got a couple minutes left, so we'll touch on a couple like lip service things. All right, so we are not data scientists. We're none of these things. We thought it'd be fun to start getting through some of this stuff and using some intelligence. Like, there's got to be a way to detect this. Not with simple regexes, but maybe we can do some smart stuff. So here's the key thing. You look at this stuff, you're like, your mind is blown, I don't understand it, but you know it's not normal. You look at any of these things, this is not normal. If this shows up in any of your event logs, you know you've got some research to do. You're not going to know what happened exactly, but you know that there's something to do. Ryan Cobb gave a great presentation yesterday about PS-AMSI, an example of like minimal obfuscation that lets you bypass some AV that have static SIGs. But when people are going like to the wall with obfuscation, they have now taken this desire for being like surreptitious and hidden and turned it into this spotlight that's like, look at me, I'm here. But how do you actually make that happen? So here's one of the first things you might think about. On the right, you see we did some measurement against PoshCode, the popular PowerShell repository, and took a look at what are the character frequencies like across all the scripts in the repository. And it looks kind of like if you've ever been on Wheel of Fortune or anything like that, you might recognize some of that character frequency, or if you've done any crypto, people do this a lot for breaking. On the left-hand side, you see that the character frequencies are so different. There's a big difference between tick being 20% of your script and E being 9. Like, there's a huge difference there. But that's one thing to say it, but how do you actually start to go down the path of detecting it? And the answer comes from a bunch of people in the information retrieval space. And I'm showing math on this so that we look smart, but we're not, we're just fun people. So cosine similarity, the idea there is, we're used to determining the angle between two lines. We've done it with a protractor. If you represent it as numbers in a matrix, there's just some math you can do on two numbers to detect the distance between, or the angle between them. So the idea being that two lines that are very similar are basically like touching. two lines that are very dissimilar are at like regular 90-degree angles. So that's two lines, that's two dimensions. But what the people in the information retrieval space have done is said, what happens if we take that exact same thought and apply the exact same math to not just 2 numbers or 3 numbers or 10 numbers, but what if you do it to something like 26 numbers, right? The percentages of E, whatever. So from there, you get this idea called cosine similarity or vector similarity. Now you run that on all the scripts in Posh code against the average script in Posh code, and some things start to really pop out here. So that symbolic, that was one of our examples. That is a 0.157 similarity. It's just a number, but it was very dissimilar from everything else. Invoke obfuscation result, kind of the same thing. So these two things pop out a ton compared to all the other guys where their similarities are grouped up. If you take a look at the distribution among all of Posh code, most things are pretty similar to each other in their character frequencies. What you can do now is take the 3,500 scripts on Posh code and look at the ones that are below, let's say 0.8, and manually that's not really that much. And when you do it, you start to see like, yeah, these things, like, they're kind of sketchy. Some of them were, part of contests or whatever, like, see how short you can make a PowerShell script to display a Mandelbrot fractal or something like that. So legit stuff. So, it actually finds some good numbers here.
So after we got to this point, we realized, we really should test this against more data. So how do we get more data? Well, last year, Microsoft ran a little contest called Underhanded PowerShell, inviting the community to basically submit ways of, to submit samples of obtuse and obfuscated PowerShell commands to basically get around certain checks, and basically to see how creative people could be. So it's almost like you were asking for this. I don't know, maybe.
Might have been.
I don't know. And so we really said we need to build a huge PowerShell corpus because there isn't one today. And so these are some of the places that we looked. But the very first thing we decided upon is that when we do this, we're going to do it appropriately and we're going to do it politely.
Politely.
And how do you politely build a corpus? Well, you'll see this sample that Lee wrote to basically scrape all of GitHub for every PowerShell project. And you see the blue part. The blue part is the actual code that scrapes GitHub. The red part is Canadian. All of it's Canadian. Because Lee is Canadian and he's so polite and it's like throttling. He built all this stuff in just to be really nice.
So generous. But mad props to GitHub on this. So when we first started doing this, took a look at the GitHub APIs and it's like, oh, there's about 10 million GitHub repos out there. So very slowly doing this and it's like, we got some time. My machines are chunking, following the limits and all that kind of stuff. And at some point, it's like, the end is nigh. We're almost done. Then it gets to like 11 million, 12 million, and I'm like, what? I look again, it was 100 million.
This was 1 month in.
Yeah, and we're not going to be waiting for a year for this thing to finish. Reached out to GitHub, and they're like, oh yeah, let's just run a little SQL statement and we'll give it to you, no problem. A couple hours later, had all the PowerShell in GitHub, so mad props to them for helping out.
Yeah. So it turns out the most polite way is just to ask the people with the data in the first place. So yeah, so big thanks to GitHub on that. But the biggest thing is to everyone who's ever contributed a PowerShell script. So we don't have time to read these right now, but if you've ever submitted a PowerShell script to any of those platforms, TechNet, PowerShell Gallery, GitHub, any of those, can you just raise your hand real quick? Here? Awesome. Thank you so much because you totally made this research possible. So give yourselves a hand on that. And fun fact is your contributor name is buried in some interesting places in the code that we'll talk about later, as well as this illustrious slide right here. However, when you get all this kind of data, the whole point was actually to look at it, right? And when you look at this much data, you find some interesting things. The first example that we'll show you is just sometimes you find really sad things. We found this: remove games.ps1. What's that author? Matt, oh wow, this is awkward. I didn't mean to out anyone publicly, but whoever wrote this, basically it goes in and it looks for processes of games and kills the process, and then it removes the directory. So like if the high score, I don't know where high scores are kept, but if it's in the directory, then this is really, really upsetting. So major buzzkill.
Yeah, but like all lulls aside, we did find some stuff that kind of concerned us. We did find a underground resistance movement that was like trying to work to topple governments to the very, very highest level. You'll kind of see some of the crazy intelligent stuff they've done here. I'll give you a second to read it, but yeah, flooding those logs of the website is totally going to be your form of resistance. Yeah, resist!
So anyways, we got a lot of data. We got a lot of scripts from a lot of places, over 400,000 scripts, over 28,000 authors, and then we also contributed about 4,000 of randomly selected scripts and ran them through different obfuscation frameworks to have that to our data set. And so the interesting part here is that we manually labeled about 7,000 scripts. And
you know that this repo here, when you think about the humanity, so uncompressed, it's about 4 gigs of text. I don't know if you've ever been on Project Gutenberg, but like the complete works of Sherlock Holmes are like half a meg. It's ridiculous amount of humanity that people have been typing and pounding and solving problems and sharing it with the community. It's amazing.
It also helps in PowerShell.
Right. So yeah, we need more data. But here's the thing. So what we started to realize was with all this data, what we thought here was we had a really great, when we looked at the stuff that was below 0.8 in that similarity measurement, it's like, this is pretty good. We're doing a good job. We're finding obfuscated stuff. But when you start to do things like, I've actually, painfully, you think hacking is fun. In this, hacking looked like, open up a script. That's good. Put it aside. Open up a script. That's bad. Put it aside. It's painfully boring, but we spent a lot of time doing it. And once you have the magic of labeled data, then you're able to do things like, to say things, how effective was that? So this is an example from Ryan Cobb where he said, well, what happens if you start tweaking that 0.8 number? Do you start getting more or less false positives? This is what you come up with. It's actually a pretty good thing. So 90% of the time, when that algorithm said that it was obfuscated, it was. But here's the big thing. The other big metric that people use in any sort of information retrieval is called recall, which is of the actual obfuscated stuff. And now we had all this labeled data. Of the actual obfuscated stuff, how much did you find? And this was the big failing here, 37%. So it's a pretty high signal, but you're still missing a lot of stuff. So you might bring it in to another framework, for example, as some sort of like, when you're using it in combination with other things, but it's not the bee's knees. It's not everything.
so surely we can do better.
This is PowerShell. We have the power. We can do better.
So if you think about PowerShell, it has to be able to parse itself, right? So we talked earlier about token obfuscation. So PowerShell looks at this command and parses it up into all these tokens, right? You have parentheses, format operators, commas, etc. But what it also does through the abstract syntax tree, or the AST, is it looks at the relationship between all those things. And so this kind of visibility allows us to basically enumerate and extract all this information, or what are called features, from any given PowerShell command or script and look at the relationship between them. A really great tool for using this is called the PowerShell AST. So you can just run install-module show ps-ast and get this really nice little GUI tool that's out there to basically type in any command or script and then explore the AST structure. So what this allowed us to do is instead of only having character frequency of the entire command, we could basically start to do things like what percentage of the script is nothing but commandlets, or is strings, or is methods, or things like that. We can also look for language operators like how many assignment or binary or unary operators or invocation operators are there. What about array size ranges? We can start to pull in that kind of data. And then for every single one of these types, strings, methods, commandlets, we then perform all that character frequency analysis only on that type, as well as the whole as well. So now we have character frequency just on commandlets, just on strings, just on methods. And a lot more than that, we have like the max, min, medium, length. We do entropy, white space density, character casing, all this kind of stuff. Basically getting as many features as we possibly can from every single component of any input command. So when you put in any single command, any single script, what you get out are how many features?
5,000. That sounds great, right? Oy, what are you going to do with 5,000 features? Sounds like a bad idea. The thing is, what do we do with them all, right? So there's a technique that people can do where you say, hey, Debo, this thing has 14 A's. Is that okay, or is that a bad thing?
Sounds questionable.
Okay. hey, Debo, this thing has the format operator 800 times. Is that okay or bad?
Yeah, I wouldn't place money on it.
Okay. So that's one approach. We decided to not take that approach. The other way to do it is to say that you can do a formula on these 5,000 numbers where you say every feature, so these are the F1, F2, give them a weight. Maybe this is worth 20% of how important you think it is, and just it's some very, very simple math. Weight times feature, add it all up, and if that number goes over a limit, hey, then maybe that's obfuscated. So that's called a linear regression when people do that. When they make a formula over weights and features, that's the thing there on the left that kind of makes this little dot scatter, and then you can say that anything above this line is obfuscated and below the line is not. Then there's another thing that you add to, which is called a logit function, and that makes sure that you're scaling all of the measurements between 0 and 1, otherwise the numbers go out the window.
Too logit to quit.
Yeah. And so you combine those two things, a linear regression and a logit function, and that's called a logistic regression. That's just the word for it in statistics. We decided to start pounding on that. So great, I got more math. Look at how smart we are. There's like sigmas and betas and all that kind of stuff. So we're smart, and when you start to do that, you start to get other numbers. But the big thing we still didn't answer is, how do you answer the weight, right? Like, Debo is a great guy, but I'm not going to trust him when I'm talking about 4 gigs of PowerShell text. And how do you know actually how you're doing when it comes to, is it obfuscated or is it not? Now, that's where you have something called a gradient descent. So the idea there is you start off, all those weights, they're just random. And what you do is you run that command against all of your scripts that you've labeled where you know that it's obfuscated or it's not. And it's going to give you a number. This formula will say, I think this is obfuscated. And since you know it is or it isn't, if it's wrong, you figure out how wrong it was, feed back that error into all those weights. And if it was right, you're good. You keep on going. So you do this a lot. This is kind of the benefit of computers over Debo, is that you can do it a lot, run it overnight, whatever, and start to get the computer figuring out what is the ideal weights that take all the stuff that you found in the wild and to tell you whether it's obfuscated or not. So, going back, so we were pretty good before having a precision of 89%. So of the stuff that it said was obfuscated, it was pretty good. Recall, 37, that was kind of the issue here. So
For the red teamers in the house, what we're about to show you is the blue team equivalent of getting DA. So if you didn't, this is what's about to happen right here. So how did our
see what popping calc looks like? Here we go. 94%. This thing now is 10 times better at finding obfuscated content with half the false positives. Crazy. We can take some questions after. Now here's the thing. What about stuff like that is like to-the-wall obfuscation, but what about stuff that's just kind of sketchy? Like, you know, I don't know for sure that it's obfuscated, but I would like it if an intern was reviewing the logs and said, can I check this out for me, please? So here's an example on the right. You know, that's not the kind of crazy stuff that you saw before, but it's kind of weird. It's kind of off. When you do that, it's still amazing. So when you broaden the net, maybe you're in the middle of a response and you want to broaden the net and find anything that is kind of a deep style of obfuscation, it still does amazing. So 88% of the stuff that it now finds is obfuscated and sketchy, still with only 5% false positives. And that's the thing that you're willing to pay when you're doing a deep investigation on a system. But here's the thing. This now becomes 97% of in the wild obfuscated stuff. So all that stuff you found is now 97% of in the wild obfuscated PowerShell. It's crazy. Now what about other things? So, you know, this was kind of fun to go down that path. There are tools out there. We were able to take all this data, dump it into CSVs, and there are things out there where you can dump it into like a machine learning studio and find other algorithms that can do things that aren't just like linear logit functions and all that kind of stuff. And it turns out this has ended up performing amazingly against in the wild kind of machine learning crazy stuff because we had so much data based on the AST and the structures of the scripts themselves.
So in a minute and a half, we're going to do a demo. And basically, there's 3 parts of Revoke Obfuscation. The first one does nothing about finding obfuscated stuff. It's just there for colors and ASCII. That's literally all it is. So if you run the command Revoke Obfuscation, you get stuff like this. Just kind of like a little, kind of lulls what's happening there. And then at the bottom, what you'll see is there's stuff that's nothing but fun. Really fun stuff. Tutorial, if you want a colored README, that's literally all that is. Fun facts, when you look through all this data, you find a lot of really interesting things. There are fun facts in there. ASCII art. We're not the only ones to do ASCII art. When you have almost 500,000 scripts, you find other people's amazing ASCII art. Want a random sample? Check it out. Also, if you want a random set of quotes, you can do that. And then credits, again, if you want to potentially see your name pop up, it'll randomly select a little sampling of all the contributors out there.
You might have to run it a couple times.
However, if you actually want to find evil, well, we tell people, get to PowerShell 5, turn on script block logging. Well, what do you do with that? Well, how about you take the script block logs and reassemble all the scripts out of them? So you can use that with get win event and sweep all your systems, pull it back in memory, and then reassemble those, or just pull back the raw EBTX files, reassemble all the stuff. This function will do that. So now you have no excuse. You can turn on that logging, reassemble scripts, and then pipe it to the real magic, measure RVO obfuscation, and there it is, chewing through every single one of those scripts saying, obfuscated or not obfuscated, on average less than 300 milliseconds for any script, and there you go. And the results are PowerShell objects, and basically it contains the full content of the script, and basically is it obfuscated or not. Also, if you dump it out the disk, it'll tell you that. It gives you the time it took to extract the features, the time it took to measure the features, and then all the features, all 5,000 of them, are in that exact object, so you have all the information there.
How's that? Anybody want Revoke Obfuscation?
So the very last thing, we want this to be useful for people operationally, so we build in a ton of different ways you can whitelist content. So as you operationalize it in your environment, when you review the stuff it comes up with and says it's obfuscated, you can say, no, it's good, drag it into a whitelisting directory, you're good to go. We want to make this really usable for the community. And with that, how do you get it? It's on my GitHub here under Revoke Obfuscation, or you can just download it directly from the gallery. So any PowerShell prompt, just install -module, revoke -obfuscation, and within 30 seconds, you can be installed, up and running, ready to go. We also released a white paper in association with this, which is that second link, and then a few references to some of the tools and research that's come before us, just looking at detecting PowerShell in general. With that, we're at time. Thank you very, very much for your attention. Please find us and ask questions. We'll kind of migrate towards the back to pay respect to the next